Hey everyone, my name is Charlie Kobo, and this is my video lab report of falling objects motion. So to begin with, we'll be using Newton's second law to analyze the motion of an object with a non-constant net force acting on it, with those forces being gravity and drag. And the reason why we're interested is because using the models that we set up here, we can predict any object's future projectile motion due to gravity and drag, such as football, missile, bomb, or even an apple. And so to do that, I'll explain the two models in a couple slides, but we'll take our net force to calculate our new velocity in our velocity update formula, and then we'll take our new velocity derived there to derive our new position through the position update formula, and we'll perform this iteratively as the object goes through time. And so this is what I'll be dropping today from 1.3 meters high up. And I chose this book because I thought its large surface area will be good for increasing the drag/air resistance force. Falling, like so. And this is what it all looks like in Tracker, where all the data is extracted. Because we only care about the motion in the y direction, we can just focus on the data, the y component of the data. You can see in this graph, the motion of the object seems to follow a nice parabolic slope right like that. So now we can derive two models, one with drag and one with no drag. By a free body diagram, the first one's net force calculation is just gravity, whereas the second one is gravity plus drag, with drag being defined as in the lab instruction. This is what both models share as initial assumptions, and this is what it looks like in GlowScript, and this is what they have different, as I said before, just coded up for no drag and with drag, with a proportionality constant just determined by trial and error to see what fits our data the best. And I like to note, because our drag force grows with velocity and our gravity remains the same, our second model predicts a point of max terminal velocity for the book's motion. And after we run both models, we can extract that data and put it in Excel, and this is what it looks like all plotted together. The blue dots you see are the observed points taken from Tracker. The yellow line, or yellow-orange, is our model with no drag, and the gray line is our model accounting for drag. And these are the velocities taken from both models, with the blue being with drag and the green being no drag. Notice how the model with no drag just has the velocity increasing at a constant rate, presumably forever and ever, whereas our blue model with one that does account for drag has the velocity start to lip off and might potentially reach an asymptote of maximum velocity. And so going off that terminal velocity case, even if we throw that ball down, as I coded in the assumptions here, we'll still have our book object, whatever, reach a maximum velocity. And when I run it in GlowScript, it looks a little something like this. You can see in the bottom, the very right-hand value is the printed velocity, which converges around a number, that number specifically. And when we zoom in on it, you can see that the gravity force and the drag force look proportional and are pointing in opposite directions. So it seems like our net force must be zero for our velocity to stay constant like that, hence our terminal velocity. So overall, I thought that my model calculated the motion of my book pretty well. My model with no drag hit the ground before the model with drag, of course. But also, in terms of errors, I like to point out how this last point right here really doesn't fit the parabolic motion of the previous points before it. I'm thinking that might be because the book truly hit the ground sometime in between that last point and the point before it. So in terms of doing this experiment better, maybe I could have used the previous point to better predict my model for drag and give a more accurate model so that I don't have some under-predicting here and an eventual over-predicting here. And there are also times where I was pretty unsure of my measurements, because in Tracker, the frame shot of each or of the book would be a blur, and I would arbitrarily just choose to measure the very bottom of the book of that frame, and maybe I think I could do a better job for accounting for that by putting a meter stick behind the book so that I can use that specifically to get a better data point. Overall, I was pretty happy with this experiment, and that is that. Thank you.